The S-band is part of the microwave band of the electromagnetic spectrum. It is defined by an IEEE standard for radio waves with frequencies that range from 2 to 4 GHz, crossing the conventional boundary between UHF and SHF at 3.0 GHz. The S-band is used by weather radar, surface ship radar, and some communications satellites, especially those used by NASA to communicate with the Space Shuttle and the International Space Station. The 10 cm radar short band ranges roughly from 1.55 to 5.2 GHz. In the U.S., the FCC approved satellite-based digital audio radio service (DARS) broadcasting in the S-band from 2.31 to 2.36 GHz, currently used by SiriusXM Radio. More recently, it has approved for portions of the S-band between 2.0 and 2.2 GHz the creation of mobile satellite service (MSS) networks in connection with ancillary terrestrial components (ATC). There are presently a number of companies attempting to deploy such networks, including EchoSatellite Management and Terrestar. The 2.6 GHz range is used for China Multimedia Mobile Broadcasting, a satellite radio and mobile TV standard which, as with proprietary systems in the US, is incompatible with the open standards used in the rest of the world. In May 2009, Inmarsat and Solaris Mobile, a joint venture between Eutelsat and SES, now EchoStar Mobile, were awarded each a 2 × 15 MHz portion of the S-band by the European Commission. The two companies are allowed 2 years to start providing pan-European MSS services for 18 years. Allocated frequencies are 1.98 to 2.01 GHz for Earth-to-space communications, and from 2.17 to 2.2 GHz for space-to-Earth communications. Eutelsat W2A satellite launched in April 2009 and located at 10 degrees east is currently the unique satellite in Europe operating on S-band frequencies. In some countries, S-band is used for direct-to-home satellite television, unlike similar services in most countries, which use Ku-band. The frequency typically allocated for this service is 2.5 to 2.7 GHz, LoF 1.570 GHz. Indostar 1 was the world's first commercial communications satellite to use S-band frequencies for broadcast, pioneered by Van der Heyden, which efficiently penetrate the atmosphere and provide high-quality transmissions to small-diameter 80 cm antennas in regions that experience heavy rainfall such as Indonesia. Similar performance is not economically feasible with comparable Ku or C-band DTH satellite systems since more power is required in these bands to penetrate the moist atmosphere. Wireless network equipment compatible with IEEE 802.11b and 802.11g standards use the 2.4 GHz section of the S-band. Some digital cordless telephones operate in this band too. Microwave ovens operate at 2,495 or 2,450 MHz. IEEE 802.16a and 802.16e standards utilize a part of the frequency range of S-band. Under WiMAX standards, most vendors are now manufacturing equipment in the range of 3.5 GHz. The exact frequency range allocated for this type of use varies between countries. In North America, 2.4-2.483 GHz is an ISM band used for unlicensed spectrum devices such as cordless phones, wireless headphones, and video senders, among other consumer electronics uses, including Bluetooth, which operates between 2.402 GHz and 2.480 GHz. Amateur radio and amateur satellite operators have two S-band allocations: 13 cm, 2.4 GHz, and 9 cm, 3.4 GHz. Amateur television repeaters also operate in these bands. Airport surveillance radars typically operate in the 2,700 to 2,900 MHz range. Particle accelerators may be powered by S-band RF sources. The frequencies are then standardized at 2.998 GHz Europe or 2.856 GHz US. The National NextRad radar network operates with S-band frequencies. Before implementation of this system, C-band frequencies were commonly used for weather surveillance. S-band is also used in optical communications to refer to the wavelength range 1460 nm to 1530 nm.